The northern route, 28 kilometers, but through 2,000-meter peaks. Central route selected, 32 kilometers. Peak elevation 650 meters. 3 lock systems required. 300 meters wide, 25 meters deep. 400 million cubic meters of rock to remove. 40 times the Panama Canal excavation. Before one blast, 180 kilometers of access road must be carved from vertical cliffs. The road is blasted from the cliff. Workers drill. The cliff face falls into the sea. A ledge wide enough for a truck appears. After every blast, workers clear by hand. No machine can reach these ledges yet. This is how roads begin in vertical mountains. Equipment arrives by sea. There is no other way. Every machine lifted ashore by crane onto a temporary jetty. 45-degree gradients. Machines climbing ledges above the sea. One wrong move, the machine goes over the edge. 6 months, 180 kilometers of road, carved from 2,000 meters of mountain, before a single ton of canal excavation begins. 10,000 workers need water, food, shelter and medical care. 200 kilometers from the nearest city. All of it built on this site. The nearest fresh water is 200 kilometers away. Workers build a desalination plant first. Everything else waits. The construction site needs 200 megawatts. No grid connection exists. Workers build the power station before they build the canal. 180 kilometers of mountain road, complete. The construction army can now reach every point of the 32-kilometer canal route.
The blast plan for this project is 4,000 pages long. Every cubic meter has been assigned a blast number, a charge size, and a sequence.
The blast sequence is designed for 40,000 individual detonations, planned over 2 years before the first charge is placed. Every cave filled with grout before it is blasted. An unstable void underground becomes a controlled collapse. 800 vibration sensors embedded in the mountain. Every blast monitored. Excessive ground movement. Construction stops immediately. The first blast is small. Cameras at 1,000 frames per second record how the limestone breaks. The model is calibrated. The real blasting can begin. Fragment size matters. Too large, the excavators cannot load it. Too small, dust fills the canyon and stops work for days. The cut-off wall goes in before the canal is dug, protecting the freshwater lens that keeps the construction alive. An unstable slope found directly above the planned route. 200,000 tons of fractured rock above the workers. The route must move 80 meters south. Route moved 80 meters. New surveys, new blast pattern. 4 days lost. The first of many adaptations the mountain forces. 40,000 blasts planned. Everyone sequenced. The mountain does not know what is coming. The first production blast removes 50,000 tons of mountain. In 8 seconds, the canal begins to exist. 40 excavators in the cut simultaneously, loading 100-ton dump trucks every 90 seconds, the mountain leaving on wheels. 1 truck every 30 seconds, carrying 100 tons of mountain, 24 hours a day, 7 days a week.
I am standing inside the canal. These walls were mountain 3 days ago. The cut is already 30 meters deep.
80 drill holes per blast face, 12 meters deep each, 960 meters of drilling for a single blast. Workers repeat this every day. ANFO, ammonium nitrate and fuel oil, the cheapest explosive that breaks the most rock. 40 tons per blast, millisecond delay detonation. Each hole fires 17 milliseconds after the last. The rock fragments instead of shattering. Controlled, precise. The dust from one blast could close the site for 6 hours. Water cannons suppress it in 20 minutes. Workers move in immediately. Night shifts run continuously. The blasting stops at midnight. The excavation never does. The mountain moves by day and by night. 400 million cubic meters of rock must go somewhere. It goes into the sea. Workers are building new land with the old mountain, 100 meters deep. The machines at the bottom look like toys from the rim. Workers inside a canyon, they are carving from a living mountain. At 120 meters, the mountain bleeds, groundwater seeping through fractured limestone. Pump trucks deployed within the hour. A permanent dewatering network installed in the walls. 50,000 liters per hour pumped away. The cut stays dry. Work continues. The highest peak cannot be blasted from above. It is 650 meters tall. A tunnel boring machine will drive through its base instead. 8 meters per day through the hardest limestone in Arabia. The TBM boring the section the open cut cannot reach. Tunnel spoil removed on a conveyor behind the TBM. Every meter of tunnel, 3,500 tons of limestone carried out. A wall section becomes unstable overnight. 200 workers evacuated at 3 a.m. Engineers on site by 4 a.m. The slope redesigned by 8 a.m. Rock bolts installed in every meter of cut wall. 180,000 rock bolts, holding the canyon walls open against the mountain's pressure. After the rock bolts, shotcrete seals the face. The mountain converted from fractured rock to stable engineered wall. Markets react to the bypass groundbreaking. Hormuz risk premium drops $8 per barrel. The canal saves money before it carries a single ship. 16 kilometers of open cut. Halfway. 200 million cubic meters removed. 200 million still to go. The TBM breaks through. Tunnel meets open cut. The full canal route connected for the first time. Underground to open air. Full depth reached in the first section. 25 meters below sea level. 300 meters wide. Workers standing on the future canal floor. Maersk signs the first transit contract while the mountain is still being demolished. $50 billion in shipping committed before the first ship can pass. 250-meter walls. Workers the size of ants against them. A canyon carved from a mountain in 3 years.
250 meters straight down, workers at the bottom, machines working beside them. The Panama Canal took 10 years to dig. This has taken 3.
The last major blast. The main excavation complete. 400 million cubic meters removed. The canal route clear from sea to sea. The excavation complete. Workers who have spent 3 years removing a mountain stand at its bottom and celebrate. The blasted rock face becomes the outer form. Workers install the inner form. The canal wall poured between them. The canal wall must resist the pressure of 25 meters of water pushing outward. The rebar cage resists that force. Workers place every bar by hand. The mountain wall becomes concrete. Section by section. The raw rock hidden behind the permanent lining that will touch the sea. The concrete is waterproofed from behind. The mountain's groundwater pressing from outside, the membrane keeping it out. The canal floor, 1 meter of concrete, smooth enough for supertankers. Workers pouring the surface that will be underwater forever. 2 kilometers of finished canal. White concrete walls, smooth floor. The mountain converted into a waterway. Bollards, lights, markers. The canal is lining. Workers are making it navigable, turning concrete into a shipping lane. The lining advances from both ends simultaneously. The canal becoming navigable kilometer by kilometer. The tunnel sections lined with precast segments, the same method as metro tunnels, scaled for ships instead of trains.
The canal can be emptied in 72 hours for maintenance. Pump stations built into the walls. An engineering requirement no previous canal has needed. 32 kilometers of lined canal, the waterway complete. What remains? The 3 lock systems that will raise and lower 300,000-ton ships. The lock basin, 400 meters long. The Eiffel Tower fits inside it lengthwise, workers carving it from the rock at the canal entrance. The lock wall holds 400,000 cubic meters of water. The rebar cage for one wall weighs 8,000 tons. Workers place it bar by bar, 15,000 cubic meters in 60 hours. The biggest single pour of the project. The lock gates, fabricated in South Korea. 65 meters wide, 30 meters tall, 3,000 tons each. Bigger than anything ever built for a canal. The gate sections arrive by ship, too large for any road. Craned from the vessel at the canal mouth. Workers guide them to their launching platform. The gate is floated in. No crane large enough exists to lift it. Winches pull it millimeter by millimeter to its seat. The hydraulic system moves 3,000 tons against full water pressure. Workers install the rams that make the impossible gate swing. The lock fills and empties through underground culverts, not over the gate. A supertanker lock chamber fills in 12 minutes. The control building is built into the canal wall. Workers and computers managing every cubic meter of water movement. The second lock, at the peak of the canal route. 650 meters above sea level. The walls 45 meters tall. The engineering highest point of the project. The third lock completes the sequence. Persian Gulf, up, over, down, Arabian Sea. 3 lock chambers. 1 mountain crossed. A supertanker enters at sea level. Rises 650 meters through 3 locks. Descends. Exits. The Hormuz Strait bypassed completely.
The water is rising at 3 meters per minute. The lock chamber will be full in 12 minutes. 3 years of construction tested in 12 minutes of water.
The canal needs an approach channel dredged on both sides. 15 kilometers of seabed removed to 28-meter depth on the Persian Gulf side. Dredge spoil dumped in a designated deep water disposal area. 50 million cubic meters of seabed material moved. The canal entrances need protection from sea swell. Workers build breakwaters from 15-ton rock armor units, placed one by one from crane barges. Every approach buoy positioned to centimeter accuracy. Supertanker captains will follow this buoy line from 50 kilometers at sea. Divers inspect every meter of underwater wall. What workers built above the waterline, checked by divers below it. Every canal needs a port on each end. Workers building the tug berths, fuel points and control facilities that operate the waterway. The canal control tower, radar coverage from 80 kilometers. Every ship on both seas visible to the controllers inside. 800 cameras along 32 kilometers of canal. Every meter of the world's most strategic waterway monitored in real time. Traffic lights for supertankers. Workers installing the signal system that manages two-way traffic in a 300-meter wide canal. A supertanker fire in a confined canal. Workers building the response infrastructure that prevents that from becoming a catastrophe. Workers removing the last traces of construction from the canal. The equipment that built it, leaving the waterway it built behind. The full transit test. A vessel through all 3 locks, 650 meters of elevation change. The design, working exactly as calculated. The permanent power station built inside the mountain wall. Workers installing turbines that will run the canal for 100 years. 8,000 workers, 30 nationalities, 6 years, 400 million cubic meters of mountain. A canal where none existed, 32 kilometers, 3 lock systems, 400 million cubic meters removed. The world's most strategic canal, complete. The last worker